Area of a sector of a circle. Welcome, everyone. Today, we are going to explore the area of a sector of a circle. Now, before we dive into the calculations, let's quickly recap what we've already learned. In our previous lesson, we defined a sector as that specific portion of a circular region that is enclosed by two radii and an arc, essentially, a slice of the circle. As we move through today's lesson, you'll see that finding the area of this region doesn't actually require us to memorize a brand new, complex formula. Instead, we are going to derive it ourselves by simply understanding that a sector is just a fraction or a piece of the entire circle's area. By the end of this session, you'll see how easy it is to calculate this using the logic of parts and wholes. Conceptual derivation, the unitary method. Now that we have established what a sector actually is, that slice of a circle bounded by two radii, you might be wondering how we actually calculate its size. Instead of trying to memorize a complex new formula, I want to introduce you to a very powerful and intuitive concept called the unitary method. The unitary method is a logical approach where we first find the value of a single, tiny unit, and then scale it up to the size we need. In our specific case, we are going to find the area of a sector with a central angle of just 1 degree. Once we know the area for that 1 degree slice, we can simply multiply that value by whatever angle we are actually interested in to find our final answer. This logic is exactly what we are going to break down step by step in the next few slides. Step 1. Consider the full circle. Now that we've established that we can find the area of any sector by using the unitary method, let's start with the most important building block. Step 1. Considering the full circle. Think about it this way. A complete whole circle is actually just a special type of sector, one where the central angle covers the entire rotation of 360 degrees. Because we are using the unitary method, we first need to know the total value we are working with. As you may already remember from our previous lessons, the formula for the total area of a circle with a radius of r is pi times r squared. Step 2. Find the area of a 1/circ dollar sector. Now that we have established that a full circle represents a central angle of 360 degrees, let's apply the unitary method we mentioned in the previous slide. If a 360-degree angle corresponds to the total area of pi r squared, we can find the area of just a single degree by dividing that total area by 360. So, the area of a 1 degree sector is equal to pi r squared divided by 360. This gives us our single unit value, which we will use in the next step to find the area for any angle we need. Step 3. Find the area of a sector with angle \theta dollar. Now that we have found the area for a single degree, let's bring it all together to find the area for any angle we might encounter. If we want to find the area of a sector with a central angle, which we will call theta degrees, we simply take that 1 degree area we just calculated and multiply it by theta. So, the area of the sector equals theta multiplied by pi r squared, all over 360. If we rearrange this slightly to make it easier to work with, we get our standard, final formula. The area of the sector equals theta divided by 360, multiplied by pi r squared. Before we move on to a real-world example, let's quickly define our variables so there is no confusion. Theta represents the central angle of your sector, measured in degrees. The letter r stands for the radius of the circle. And finally, pi or pi is our mathematical constant, which you can approximate as 3.14159, or more commonly in your calculations, as 22/7. Real-world application, the pizza slice. Now that we have derived the formula mathematically, let's look at how this applies to a real-world scenario to make it more concrete. Imagine you have a large, circular pizza. When you take a knife and cut a single slice from the center, you are essentially creating what we call a sector of that circle. As you can see from our previous derivation, the actual amount of pizza you get, the size of that slice, depends entirely on the angle at which you make that cut from the center. A wider angle means a larger slice, and a narrower angle means a smaller slice. To put this into practice, let's work through an example scenario together. Suppose you have a pizza with a radius of 14 centimeters. Now, imagine you cut a slice with a central angle of 45 degrees. Based on the formula we just learned, how would we calculate the area of this specific slice? Let's move to the next slide to solve this step-by-step. Step-by-step solution. First, we need to identify our given values from the problem. We have a radius, r, which is 14 centimeters. Our central angle, theta, is 45 degrees. And for our calculations, we will use the value of pi as 22/7. Second, before we plug anything in, it is vital to write down our formula clearly. As we learned in the previous slides, the area of a sector is equal to theta over 360 multiplied by pi r squared. Third, let's substitute our specific values into that formula. This gives us 45 over 360 multiplied by 22/7 multiplied by 14 squared. Fourth, to make the math much more manageable, let's simplify. If you look at the fraction 45 over 360, you'll see it simplifies down to 1/8. Next, we calculate 14 squared, which is 196. Now our equation looks much cleaner. It is 1/8 multiplied by 22/7 multiplied by 196. Fifth, we perform the final calculations. A great trick here is to divide 196 by 7, which gives us 28. This leaves us with 1/8 multiplied by 22 multiplied by 28. If we multiply 22 by 28, we get 616. Finally, when we divide 616 by 8, we arrive at our result. So our final answer is, the area of this pizza slice is 77 square centimeters. Now that we have the pizza scenario in mind, let's walk through the step-by-step solution together to see how we apply the formula we just derived. As we move to the next slide, I want you to pay close attention because I'll be highlighting some common pitfalls where students often lose marks during these exact types of calculations. Common mistakes to avoid. Now, before we wrap up our lesson, I want to pause and discuss some common pitfalls. Even if you understand the concept of the pizza slice we just calculated, it is very easy to trip up on the details during an exam. Let's look at 3 specific errors that students often make when calculating the area of a sector. First, a very common mistake is confusing area with arc length. It is easy to get these two formulas mixed up because they look so similar. You might accidentally use the formula for the length of an arc, which is theta over 360, multiplied by 2 pi r instead of our area formula, which is theta over 360, multiplied by pi r squared. A great way to keep this straight in your head is to remember that area is a two-dimensional measurement, so it must involve r squared. Arc length, on the other hand, is a one-dimensional distance, so it only involves 2r. Second, please be very careful with diameter versus radius. In many math problems, especially tricky ones, the question might provide the diameter of the circle instead of the radius. If you take that diameter and plug it directly into the formula as r, your final answer will be incorrect. Always take a moment to check the given information. If you see a diameter, remember to divide it by 2 to find the radius before you start your calculations. Finally, watch out for incorrect simplification. When you are working with the fraction theta over 360, try to simplify that fraction as much as possible before you multiply it by pi r squared. As we saw in our pizza example, simplifying 45 over 360 down to 1/8 made the multiplication much more manageable. Simplifying early helps keep your numbers small and significantly reduces the chance of making a silly arithmetic error. Keep these tips in mind, and you'll be well on your way to mastering this topic. Key takeaways. All right, we have reached the end of our lesson, so let's wrap everything up by reviewing our key takeaways to ensure you have a solid grasp of the topic. First, remember the fundamental concept we discussed during our derivation. A sector is not some entirely separate entity, but simply a fraction of a circle's total area. Think back to our pizza slice example. The slice is just a portion of the whole pizza. Building on that, it is crucial to understand the relationship between the angles and the area. The ratio of the sector's area to the total area is exactly the same as the ratio of the sector's central angle to 360 degrees. This proportional relationship is what allows us to use the unitary method we explored earlier. To put this into practice, you should memorize and be able to apply the standard formula. Area of a sector equals theta over 360 multiplied by pi r squared. Just remember that theta represents your central angle and r is your radius. Finally, always keep an eye on your units. Since we are calculating area, your final answer must always be expressed in square units, such as centimeters squared or meters squared. If you have reviewed these points and practiced the step-by-step solution we walked through, you are well on your way to mastering this topic. Great job today!